how's it? Thank you for joining me. My name is Murray. We've chatted a few times, kind of on the social medias, but really, what I'd love to do is take the opportunity to have a chat with you and see. Well, what I'm trying to do is I'm trying to create this probably a podcast or something like a podcast called Atoms to Bits, which is my opportunity to direct the conversation, kind of a public conversation about various things BIM. Um, from my side, I tend to be on the kind of reality capture or scans BIM side of things, although I've been in architecture for an excessively long time now, so I know the whole process, but now I'm at the beginning of the process, at the scans BIM process. Um, and so Atoms to Bits is my opportunity, my soapbox, if you will. Um, and that's really me. And so I got you to join me, and you are basically the chief evangelist for Open BIM and open source. Can you tell me a bit about that?
Yeah, sure. So I've been involved with open source for a very long time. It's been well over a decade, and many different fields of open source. So looking at open source in desktop computing, so things like Linux, desktop environments, looking at open source from the creative applications like Blender and the GIMP and so on.
Mm-hmm.
And I was trained as an architect, and naturally, when you try to combine open source and the AEC industry, there's only a few things which intersect, and one of those things is an open data standard known as Open BIM,
Mm-hmm.
and where we say, okay, let's go and standardize the way data is structured, and because of that standardization, you gain interoperability, you gain the ability to build systems independently of one another. You get standardization, you get the freedom of being able to own your own data rather than kind of renting the data based on the whims of somebody else who structures your data. And that's very conducive to open source software.
Yeah, absolutely. So you mentioned like an open data standard and open BIM. How is that different from, well, IFC basically? Yeah.
It's the same. So basically, I think it's good to distinguish between open source and open BIM. So
Yeah.
if you talk about data, that's what open BIM is about. It's about the data. It's not about the tools you use to interact with the data. It's about the data itself. And open BIM is an open data standard applied to BIM, the way you digitally describe our buildings.
Yeah.
And IFC is one out of many open data standards that apply to BIM. It's not the only one. There's others out there, like BOM, there's the speckle object model, there's hyperelements, there's brick schema, there's the haystack, and so on. So there's a lot out there. But I guess IFC kind of stands out because there are a few things which make it unique compared to the others. And that's why I tend to interact with IFC quite a bit more than the alternatives.
And what are those things that are unique? So IFC, IFC. Why is IFC better than the alternatives? There seem to be an awful lot of alternatives over the last kind of year or two. Whereas IFC, although it's had its problems for many years, it's got age on its side, really. That maybe it's ironed out a few of its creases.
I don't think that you can say it's better or worse. But you can say whether it's more appropriate for a certain task. So one of the big differences in IFC is that it's an ISO standard, and that immediately makes IFC a very good contender for certain things, like when governments want to require BIM data in their contracts. So for example, here in Australia, it's a legal requirement that you cannot specify proprietary data. And so they go, hey, it's an ISO standard, tick, and that's why the Australian government tends to request a lot of IFC information. So it makes it more appropriate for that use case. Being an ISO standard also means there's a certain rigor in its in the process. So for example, they don't there's a process required to make sure that it doesn't overlap with other standards or it integrates with other standards. So for example, IFC has integration with things like GBXML or X3D and now with GLTF. So it doesn't, there's a lot of places where IFC doesn't recreate the wheel and plays nice with existing standards. So that's one of the main differences, that it's ISO.
Yeah.
But another huge difference is that IFC is, I think, the only one which had the what's the right word here? The bravery to kind of tackle the entire industry.
Yeah.
So most of these schemas, these open data schemas, only tackle a portion of our industry. Like GBXML, it focuses on energy modeling, for example. And a brick schema, it focuses on building sensors during the BMS operations phase, and outside that, it just stops.
Well, yeah, I've actually been thinking about that a little bit about IFC, that it's actually worthwhile to think of its limits as well. And while I completely agree with you that there's energy data standards and such, as I've slowly researched IFC, one thing to realize is that it's specifically about buildings. IFC is huge and encompasses, I like the schema in that you can describe almost anything in a building in IFC. But these days, I get people asking about kind of building models, like BIM models or 3D models, which are metaverse type things, or which are completely digital and never going to be physical. And that's not actually what IFC is for. It's quite interesting to say that while IFC encompasses the AEC industry fantastically, it only encompasses the AEC industry. And with digital standards these days, like NVIDIA was talking, NVIDIA is incorporating IFC into its USD standard, I think. And that's where I would say USD is much broader than IFC. But IFC is obviously broader than the energy modeling standards you mentioned.
There's a few things you touched on. IFC is designed for the physical built environment, and that's more than buildings. It includes infrastructure as well, for example.
Okay.
But you're right that it seems to be focusing on the physical world and the semantics that the physical world requires. Now, I'm not an expert on metaverse, so if there are certain semantics that the metaverse requires, I'm pretty sure that's not the top priority list for the IFC schema. So I wouldn't be surprised if it was less than appropriate.
Yeah.
USD, however, is definitely not designed to describe the physical world from an AEC perspective. So
yeah.
It has a significantly smaller scope. It's designed more for the CG world.
Okay.
So, for example, geometry. IFC has parametric definitions for most of the common profile definitions in our industry, things like I-beams, angles, and RHSs, and so on. Whereas USD, it doesn't have any of that. So immediately, that makes it completely inappropriate for things like structural analysis or just any sort of structural modeling or most buildings. So I think there's, for the physical world, yes, IFC is definitely catered for the physical world. I can't speak much about metaverse.
Well, that's fine. And then, it's nice for us to be able to focus on that. We're focusing on real physical buildings and not push it around too far. You've spoken a bit about Open BIM and what that means, and the fact that by getting ourselves out of proprietary data, what we're actually trying to do is communicate better. I was speaking to Patrick Chopson from CoveTool last night, and for CoveTool, who are energy modeling kind of softwares, it's transferring that building data between a growing number of kind of startup companies which provide various niches, whether it's energy modeling or reality capture or there's this like web-based ecosystem of more and more little companies which aren't Autodesk, and who need to speak to each other. We need to speak across apps more and more often, and this is where IFC suddenly becomes way better than anything that Autodesk could offer. Is that so?
Yeah, I'd say so. So, I mean, if you're a web developer, um, the analogy I like to use is that you want to deliver your application across everybody's web browsers. So you need two things. You'll need a language, and that could be HTML, CSS, JavaScript, and you'll need a protocol to transfer that language to them, like HTTP. So that means, and if you comply with those two, basically, there's open data standards for HTML, CSS, JavaScript, and the protocol, open protocol standard for HTTP. Then anybody with a web browser will be able to consume your content in a standardized way. And that's the kind of beauty of the web. And it took a long time for the web to get to where it is. Like if you remember the early days of the web when you had things like Works Best and Internet Explorer. And it's kind of like where our industry is at right now for AEC. So any developer coming to AEC, they say, okay, what's the language of digital buildings? And it's very hard. And the answers which people give are typically things like IFC or GBXML or brick schema, these open data standards that say here are the languages of digital buildings. Which language you choose depends on your use case. The one which encompasses most disciplines is definitely IFC, and definitely you just look at the suite of tools out there. The majority of BIM tools, at the very minimum, have an import-export IFC feature. The quality varies, but at the very least they have that. But you can't say the same for something like Project Haystack, for example. So after they give you that advice, you go pick whichever digital language you prefer. And then the next question is, what's the protocol? And that's another really interesting debate, which our industry is really not yet there at. And there's some really interesting solutions like Speckle, which offers essentially a protocol with a very lightweight schema. That kind of, I like to think of them as solving the problem of interoperability from the other end, protocol first rather than schema first. And so I guess once you have both of those, you're right, it does let people speak to each other a lot better.
And protocol's not IFC. Well, protocol's an IFC file type, but it's not IFC. It's not IFC as a schema. I've never thought of how we communicate in terms of both schema and what Speckle's doing, and the kind of, I don't know if I'm explaining myself, but every time I've looked inside an IFC file, I can read IFC badly, like as a text document or inside something like BlenderBIM. But that protocol, that's where either Speckle or IFC.js or IFC OpenShell comes in. Is that correct?
I guess the protocol is, how do you transfer that data? So if you take in an efficient manner, because you don't want to typically not grab everything out of a digital building. So think of how the GIS industry works. I mean, in theory, you could have a data set of the entire world, but you wouldn't need the entire world. Like OpenStreetMaps has a data set of the entire world, but you'd only extract portions of it that you're interested in. So similarly, you'd have a digital building, and you'd only extract portions of it that you're interested in, and you'd make little edits of those things that you're interested in with whatever tools you like, and then change that back in this underlying data set. And that's where the protocol comes in. How do you extract just what you're interested in, change just what you're interested in using whatever tool you like, and then stream it back? And Speckle has done an incredible work of engineering in solving that, not with the IFC schema. In fact, with any generic schema, they solved it for any generic schema. IFC hasn't solved it, but IFC has put put in place a strategy to enable it to be solved in the future. Don't forget, IFC was back in the 1990s. So what IFC has done is that it has separated the IFC schema, which says here's how we describe objects in our built environment, with the serialization method. And that serialization method is the magic sauce of how to record it in a way that computers can understand and transfer it. So for example, that .ifc file is just one possible way of storing and reading IFC. JSON, if you want to go server to server, or XML server to server, is also possible. But serialization is also just one part of the story. I mean, sure, you can store it in a language which is easier to stream or something like that, but how do you determine how best to divide up the schema? Like, for example, and this is a very difficult question. Like, if you download a wall, let's say you just want to edit some walls, you're an architect. And you edit that wall, how do you ensure that that wall has the appropriate downstream impacts on whatever that relies on it? Like that wall would have an impact on a space boundary for energy simulation. It would have an impact on a plane for a structural surface member for structural analysis. It would have an impact on a calculated quantity, which would have an impact on a cost, which would have an impact on a schedule, a construction schedule, and so which would have an impact on your LCA analysis. And so you and all these things are interrelated. And IFC has developed over decades the ways of describing these relationships. And so the next problem is, how do you chop it up?
That's super interesting. Like, there's so much to unpack. Well, hold on. So how do you chop it up? But first of all, how do you ensure that all of those downstream impacts are going to be recorded? It's a wall is. There are so many complications, or so many things that are, like, a wall will affect. A wall will affect the area of your room, the R values of your room, or the energy modeling inside that room. To get all of them to work together, and it's not a simple parent-child relationship. It's really, well, I saw. We never think of what we do like this, but I saw it. Somebody describe our industry as spatial computing, and really that's it. Are we talking, when we're talking about digital versions of our building, we're not necessarily talking about a parent-child relationship of all of the elements anymore. Rather, we're talking about three-dimensional relationships, where a wall relates to a floor or a room by proximity or by geometry, really.
Not actually. It's not geometric primarily, I would say. So IFC, for example, you can build in an. Well, it's a little bit more complex than parent and children. Most relationships do have a suggested hierarchy, like this is the parent, this is the child. But in some relationships don't have that hierarchy. It's just, this is the relationship. It's two-way, or there is no directionality. So I guess you can think of an IFC database and most BIM databases as a graph. It's a network of many nodes which have edges to one another. And so the question is, how do you split it up into meaningful subgraphs? And how do you ensure that you have these well-defined entry points into these subgraphs and the ability to mark other subgraphs as potentially stale, so that somebody can say, hey, something has changed here which could have triggered my domain. Maybe I should update it. So for example, when that wall moves or changes, it triggers another subgraph, let's say the energy modeling subgraph, that says, hey, maybe these space boundaries need to be refreshed and recalculated and resimulated, and so on, and so on. So and that's a big part of what the BlenderBIM add-on is doing. And a lot of this goes unnoticed. They see but that's actually a huge challenge that we're solving, into how to chunk these subgraphs into meaningful disciplines.
Okay.
And it's not an insurmountable goal. It's difficult, and that's why IFC has taken so long, and it's significantly harder than a homebrew solution of a wall as a box, right?
Yeah.
It's not insurmountable because you can actually count these relationships. IFC has refined them over many years. Yeah, I know there's this many. It's not perfect, but there's a lot of really smart thinking behind of it,
Yeah.
and you can chunk it. I mean, the BlenderBIM add-on has chunked IFC so far into 40 modules. We said there are 40 distinct kind of subgraphs here. Some are more related, some are less related. And this has got nothing to do with geometry. You can do an entire building without geometry.
Mm-hmm.
And these relationships are agnostic to geometry. Yes, some of them will tell you if they're related to geometry, but the geometry aspect is completely optional.
Yeah, I've always really liked that optional geometry kind of mentality of thinking about buildings, which you get with IFC. Um, you let's talk about BlenderBIM for a minute. So, BlenderBIM, your amazing product. You were just saying that you've chunked IFC into 40 into up to or 40 different modules, subgraphs, if you will. I don't understand. Um, for example, what? If maybe that's the easier way to explain it.
Yeah, so one example might be classification systems. So the ability for an element or a task or something to be classified into one of these classification hierarchies, like omni-class, uniclass, and so on.
Mm-hmm.
That's one clearly contained set of concepts in IFC, and you can quite easily make a call of saying, if you change something, will it impact classification or not?
Okay.
And so there's a pretty easy delineation there. You know, nothing's perfect, of course, but there's a good delineation there, and
Yeah.
you could, in theory, and we have, because we have chunked it up that way. You could build an IFC editor that all it does is deal with classifications. You know, it's an app that all it does is filter by classifications, color code by classifications, bulk classifications with AI or catch anomalies, and it can just be your IFC your model classifier tool.
Mm.
And it doesn't need to understand any other aspect of IFC. You know, it doesn't need to care about geometry, all the complexities of that. It doesn't need to care about energy analysis, costing, scheduling. It can just deal with classification by itself and not have any data loss or downstream impacts elsewhere in the graph.
Cool. Cool. So BlenderBIM it's it's the one example that I know of where you can create IFC natively without creating IFC in something or without creating the information or building information in something and then exporting it to IFC. BlenderBIM is the only place that I've seen creating IFC natively, and it's not just about geometry, right? So the geometry plus the thing is that BIM quickly moves on from a wall plus whatever the properties of the wall are, and quickly moves to the higher level relationships. So four walls making a room, or the volume of that room for energy modeling. What does Blender BIM do aside from let me create a wall and add a material and a property to it? Aside from like creating geometry with a few parameters.
I think it does everything. That's the short. I mean,
That's the
not
short.
everything. We're not quite there yet, but in short, we do nearly everything. So, in fact, we were able to do non-geometric relationships earlier than we could draw a wall, and that comes as a surprise to many people. So we were able to say that a wall belongs somewhere and has a classification system and is included as part of a cost schedule and has a parametric set of formulas calculating its cost.
Mm.
We were able to do that far before we had a really a nice wall drawing tool. And in some ways, I think, that's the right way to go about it. You have to first truly appreciate how your wall is to be consumed by others before you can build the wall drawing tool.
Absolutely.
Nowadays, after I've learned what I've learned during that process, I could probably do it the other way around, but for my first foray into it, I would say that would be the way I go. So you can definitely do a lot more than just draw some geometry and assign some metadata. And this is a common way people understand BIM. They say BIM is geometry plus metadata, some keys and some values. And the more you dig into IFC, you realize it's far more than that. So for example, a wall has a type, and a type typically would have a type, so it would have an architectural construction made out of various layers. And those layers would have certain thicknesses of it. So immediately, it's not just a key value pair, because you now have a wall related to a type, and it's the type which has all of the data, not the wall itself. It's the wall inherits data through the type, right? If the type has X layers, then the wall itself must inherit from the type. So you've got two objects now. And then the type would then have layers, but the layers need to be made out of materials. So then it's no longer just key values again, it's related to material objects. And so you can see how it starts building up quite a set of relationships.
Yeah. So we've been hearing for years that, I'd love for this conversation not to be about Revit, but it's a common kind of phrase to say that BIM is not Revit or Revit's not BIM, whichever way around you want. From my side, so I was in architecture for a good 15 years or so. But recently I've been only doing scan to BIM. And what scan to BIM tends to be, traditionally, even though it hasn't been around for that long, is we laser scan something, we import it into whichever software, and it's always Revit. And then we trace over the Revit model, or we trace over the point cloud in Revit, and give those walls kind of whatever parametric data you want. Which is just a material and a thickness, probably, and some kind of geometry. I would love to skip the Revit step and go, well, what do I need to know? I'm starting with a point cloud. So there are some people out there who would take the point cloud, just select the number of points which encompass that wall, and add the metadata and be done with it. You have a point cloud that's close enough to geometry. Or heck, all you actually want is a point on 2 points on the floor, and you can draw the corners of the wall. And you don't need an extruded rectangle. And maybe that's how we're all going to escape from Revit, is that if we start thinking about what it is we're trying to communicate, then the geometry seems to fall away a little bit.
Absolutely. And I mean, you made a comment there how point cloud is almost geometry. I mean, a point cloud is geometry. It is geometry. It's not almost, it is. And so there's nothing saying that your wall needs to be an extruded rectangle. Your wall could be a mesh, or your wall could just be points.
Yeah.
Or your wall could be a photograph, right? There's nothing at all that says that it needs to follow a particular geometric paradigm. And depending on which discipline you're in, you will need different paradigms. And scan to BIM is an excellent one of saying people, actually, no, the extruded model doesn't work. It's actually worse. You're actually getting worse quality information.
You're definitely losing information by trying to make the wall kind of offsettable, basically.
Correct.
We're constantly dumbing it down, which we shouldn't be doing, which we don't need to be doing. Yeah.
So there's really good research done by Thomas Kreinen on assigning IFC classifications and data to point cloud geometry and segmentation of it, and how to store that efficiently, how to extract that efficiently. So there's a lot of good research done on it, and I think there was also some Building Smart award winners in the past which focused on scan to BIM and how to do that. So it's not my area of expertise, but I know it's definitely being looked at.
Oh, I'm definitely going to do a little bit more digging. Yeah, and actually it becomes quite interesting because the work of Florent Pou in France, he's semantically segmenting the point clouds, which when it works is beautiful. You just run a point cloud through Python and get the wall or toilets or table automatically to you, rather than having a human kind of decide. Rather, if you can machine learn the point cloud, the segmentation of the point cloud, then you solve a whole lot of input problems as you're going along. That's not necessarily going anywhere.
No, definitely. There's some. I mean, there's some brainstorming happening on the OSArch forums recently about somebody doing what you're doing, and they're talking about how to chunk in this, drop this very high resolution mesh into IFC, which IFC was not designed for.
Yeah.
And we were talking about various solutions. Like one possibility is that you could have the best of both worlds. You could have your extruded kind of solid, but then you would have a texture map, for example, which would be an XYZ displacement, which would reflect the true point value. So you get that kind of really lightweight approximate model, but then if you really wanted the true detail, you could select an area and the textures can scale very, very well. Well, another example might be whether it's machine learning or really just fast, rapid modeling, like a CG amateur could do it, of just modeling simple planes, saying this is the rough plane of it, and therefore I can at the very least count the number of walls and number of objects. Like just put a box around that object and you say done, and then anybody who wants more information about that box or a single plane, like a 2D plane, not even with thickness, it then does an offset search with a certain loci around those areas to pull in the point clouds from the point cloud scan. And so, I mean, if you think about dilapidation studies or existing buildings, it's actually very little work. If you're not interested in this kind of pristine parametric BIM model, because it isn't anyway, you could just scan it and then get somebody to just walk around, do simple plane modeling, or even just like an FM. You just list the objects in the room and a single point and
Absolutely.
a little XYZ coordinate, and that's it. It's super lightweight, and you get a lot of information out of it.
Yeah.
All these old buildings where the paper drawings are long gone, the Revit files don't exist anymore, of course. You could, in very, very quickly, get a super high quality IFC, even more accurate than anything you could get you'd be modeling from scratch from.
Absolutely. So this is where I would love to be pushing things. I guess what you've got to do then is sell yourself or sell your products to everybody who wants a Revit model which they can work off. So even though creating the IFC, like you've been saying, is better, it becomes an education problem. It becomes a problem of I need to hand over information or I need to communicate information about the building. And in my case, it's reality capture, but you could be anywhere in the process. I need to communicate that information about the building, and I need to do it in a way that's kind of different to either the typical Revit way of doing it or the typical AutoCAD PDF way of doing it. We're still using new processes, which requires education of people down the line, doesn't it?
Absolutely. I completely agree.
That education is the hard part. I've really enjoyed this conversation. I'd love to carry it on one day, but shame, it's nearly 6 o'clock in Sydney. You've got an evening ahead of you. In Durban, it's 20 to 9, so I've got a full Tuesday ahead. Yeah, but I don't want to take too much of your time, and I just wanted to say thank you for coming on to my little talk show, and I'm looking forward to getting this out and seeing what other people think about it.
Thanks so much. Anytime.
Yeah, cool. Thanks very much, Dion.
Okay, see you then. Have a good
Thank
night.
you too. Ciao.